So we continue our lectures on general course of physics, and today's topic is the dynamics. The dynamics is one of the most interesting parts of mechanics, and in comparison with kinematics, this is the subject in which you try to find the reasons of why the motion happening in that very way you see. In fact, it's much better to say that we don't try to answer the question why it's happening so, or we try to just to describe the motion and to make conditions of why this motion is happening that very way. Because we can't in fact answer the question why, it's just an impossible thing. We know this from philosophy. Science just tries to describe the natural processes that happen. So, well, what's concerned dynamics on the whole? In dynamics, we have three axioms, which are also called the three Newton's laws we use to build the whole theory of mechanics. This is a fundamental theory of axioms we have to learn of by heart, that we have to understand on a very, very high level to be able to understand the whole mechanics. So now let's start these axioms. The first axiom of Newton is formulated in that way. Inertial reference frames exist. Now you will have a question, where is it? Where is the inertial reference frame and why it exists? So the inertial reference frames are the reference frames that moves with the constant velocity relatively to the stationary reference frame. Okay, so for example, if there is a ground and I can say that the ground is the stationary reference frame and here is the bird flying with a constant velocity v in the same direction every time, I can say that this bird is the inertial reference frame. Okay, so the first Newton's law says to us that these systems exist. Why so important to say that these systems exist? In fact, in the second Newton's law, when we formulate it, we use this term when we put limits on using this law. So it means that firstly we have to say that yeah, these systems exist and we can work in it. We have such a law that will work in it, and we have the system on the whole. Because if they don't exist, so there are no sense to create other laws and axioms because they will just work. So we firstly say that this inertial reference frame exists. The second Newton's law. This is the most interesting part in the axioms of dynamics lectures because there are a lot of problems with understanding of that law. So the first problem, the first mistake that many people do is when they say that the second Newton's law is that what I write now. The F, which is the force acting on the body, is equal to the mass times A. A majority of people say it in that way. In fact, this formulation is not very right. Why so? From that very formulation, we can't say anything about the reasons of motion, and we can't say anything about the consequences of the motion. In fact, it's much better to say that the acceleration is proportional to the force acting on the body and is back proportional to the mass of that body. It would be much more better because now we see the reasons of the motion. We see that the force is something that causes the motion, and the acceleration is the consequence that we see. Okay, because the body will move only if we act on it with the forces. Because of that, this would be better. But from the mathematician's point of view, these two things are the same. In physical points of view, these two things are a bit different. Now we understood it. Well, this is not all things about the second Newton's law. Another very important aspect of using the second Newton's law is that it can be used only in inertial reference frame. Inertial reference frame. So what does it mean? Imagine that the body is moving on the ground and the force is acting on it is this one. This body is moving in the direction of the acceleration A. I can write that F equals to ma, m point times A, relatively to the ground. So I will calculate this A relatively to the ground, and this law will work in that way, relatively to the ground system. But imagine now that the boy is moving in that velocity, direction with velocity v, the constant velocity v. So what can we say now about the Newton's law relatively to this very body? In fact, the law will be the same. So relatively to the boy, as he is inertial reference frame, we can write that F equals to ma, and it will be right. What does it mean? It means, in fact, that A, the acceleration, doesn't change if we calculate it relatively to the Earth surface, either relatively to any other inertial reference frames. Well, this is what concerns the inertial reference frames limit of that is put on our law. The second thing we have to understand, which is the limit, which is also one of the limits of the bout, is that this body must have very small sizes relatively to the problem we have, which we solve. So the sizes must be very small relatively to the problem we have. Okay, and the third thing I have to say about is that the mass of the body must be constant. So the mass must be constant. And if these three limits work, so then I can say, I can use this law to describe the motion of the body. Well, this is approximately all about Newton's law. You will, of course, have the questions then how to work with non-inertial reference frames, or the question how to be with the bodies that has not constant mass. So, for example, how to study the motions of rockets. And you can have the questions about the second part over a free term. I will explain it a bit later how to work in such a situation that you have a question about. Now let's go on another axiom of dynamics, and this is the third Newton's law. What does this law describe? Let me try to understand. It's one of the easiest laws in the axioms of dynamics, and it tells us that if two bodies act on each other in any ways, so if, for example, this body acts on this body with a force F, so they interact, so then the force, this body will act on this body with the same force F, but with a back direction. So the third Newton's law just says about this thing. It's quite obvious. It's not an obvious thing, but it's just a law that is quite understandable one. Well, this is all things that are important about the axioms of dynamics. And some people may have the question why there are only three laws of axioms of dynamics, why there are not four of them, for example, or two or one. Why it's so important to have only three of that laws? And it's quite a good question, in fact, and I have an answer about it because I thought about this question for a long time. Let's try to analyze what we do when we study physics. We try to describe the interactions. We try to describe the interactions, and we try to describe motions. So the motion and the interaction are two fundamental things we try to study. And we have to have the laws for both of that processes that happen, and we have to see the connection between two of them. So the first Newton's law gives us an opportunity to describe the motions, because it says that we have an inertial reference frame, so you can work in it. If there won't be the first Newton's law, so we won't be able to use the second Newton's law, and because of that, it's a very important thing to say that there is such a law that is the first Newton's law. The second Newton's law describes the motion. It describes how the motion changes, how it's happening when something acts on the body. So it tries to give us the recipe of how we can write an equation that will describe us the motion. So it's about the motion, yeah? So the first and the second Newton's law are about the motions. And the third law, it is about interactions. It says to us what is happening when two bodies interact with each other. So using these three laws, we can describe both processes of motion and the processes of interactions. And because of that, there are only three laws of dynamics.